You know, our planet is always talking to us. It sends out signals in the language of ice and water and weather and life. So today, we're going to decode those signals. We're going to investigate the clear, observable signs that our world's climate is changing, all based on research from the Union of Concerned Scientists.
All right, so here's our game plan. We'll kick things off with the planet's rising temperature, kind of like its fever. Then we'll look at what that means for our ice and oceans, see how it's shaking up our weather, and finally, check out how life itself is trying to keep up.
I want you to think of this whole thing as a detective story. Seriously, we're not looking for one single smoking gun. Instead, we're piecing together a whole web of connected clues from every corner of the globe to build a case that's, well, pretty much undeniable.
Okay, so our first and most direct clue is something we can all wrap our heads around. Just like a person who's sick, our planet has a fever. It's getting warmer.
Here's the headline number you need to know. The planet, on average, has warmed up by about 1.1 degrees Celsius. That's almost 2 degrees Fahrenheit since the early 1900s. Now, that might not sound like a lot for your daily forecast, but for a global average, that represents a massive injection of extra energy into our whole climate system.
And this isn't some random fluke. The data shows a crystal clear trend. Every single decade since the 1950s has been warmer than the one before it. It's a steady, consistent, and accelerating march upwards.
So, what's causing this fever in the first place? It's something called the greenhouse effect. Basically, when we burn fossil fuels, we release these heat-trapping gases. Think of these gases as an invisible blanket we're wrapping around the Earth. They trap heat that would normally escape into space, and that's what makes the planet's temperature go up.
And this fever isn't just something we feel in the air. Our oceans are like a giant heat sponge. They've soaked up a huge amount of this extra warmth. We can actually measure that the top layers of the ocean are getting a lot warmer. And that has massive consequences for everything from marine life to our weather patterns.
The warming even goes deep into the ground itself. In places like the Arctic, soil that has been frozen solid for centuries, we call it permafrost, is starting to thaw out. This is a huge deal, because when it thaws, it releases trapped methane, which is another powerful heat-trapping gas. It creates this dangerous feedback loop that just turns the planet's thermostat up even higher.
So the planet has a fever. How does that actually show up? I mean, it's not just a number on a chart. It is physically changing our world. And there's no place you can see that more clearly than in our planet's ice and oceans. This is one of the most obvious clues. We have satellite photos going back decades, and they clearly show the Arctic sea ice is shrinking. To give you a sense of the scale here, every single summer we lose an area of ice about the size of Nebraska and Rhode Island put together. That's a staggering amount of ice, just gone. And it's not just the ice floating in the sea. The gigantic glaciers on land are melting at an incredible rate. We're talking over 200 billion tons of ice lost every single year. It's almost impossible to picture a number that big. But try this. Imagine covering all of New York's Central Park with a block of ice that's 40 miles high. That's how much ice we're losing every year.
All that melting ice has to go somewhere, right? It flows into the ocean, and that's a big reason our sea levels are rising. It really comes down to two simple things. First, when water heats up, it expands and takes up more space. And second, all that meltwater from glaciers and ice sheets is pouring into the sea. And here's the kicker. Just like with the temperature, the sea level rise is getting faster. In just the last decade or so, the rate is more than doubled compared to what it was for most of the 20th century. This acceleration is a really critical part of the story.
But the oceans are changing in another really important way. They don't just soak up heat, they also absorb about a quarter of the carbon dioxide we pump out. When that CO2 dissolves, it makes the water more acidic. And that's really bad news for any marine life that builds shells, like corals or oysters.
Okay, so we've got a warmer planet, we've got changing oceans, but what does that actually mean for us, here on the ground? Well, let's connect these global clues to the stuff we experience every day. The weather.
Look at what's happening in places like the western U.S. Hotter temperatures and drier conditions are the perfect recipe for wildfires. What used to be a pretty well-defined fire season is now almost 2 months longer than it was just a few decades ago. And that means we're seeing bigger, more intense fires.
A lot of this comes down to one simple fact. A warmer planet means more evaporation. That puts more water vapor, humidity, into the air. And that creates this kind of triple whammy. First, water vapor itself is a heat-trapping gas.
Second, it makes hot days feel way more miserable. And third, a wetter atmosphere can dump all that moisture at once, leading to more extreme rainfall. So all these profound changes to temperature, water, and weather, they're not happening in a vacuum. They're forcing a powerful reaction from all of Earth's living things. Our detective case isn't just about physics and chemistry anymore. Now it's about biology.
Plants and animals are trying to adapt, and for a whole lot of them, that means one thing: moving. To survive, countless species are shifting where they live, trying to find cooler spots, moving towards the poles or up to higher mountains. It's like this massive, silent migration happening all around us.
So, we've followed all the clues, we've seen the planet's fever, the melting ice, the wilder weather, and life on the move. So after all that, what's the final verdict? And more importantly, what does it mean for us? When you lay all the evidence out side by side, the conclusion is just clear. This isn't one isolated problem. It's a whole cascade of changes that are all connected. It's like a line of dominoes. The fever causes the melt and the heat change our oceans and weather, and all of that forces life to react.
But the story doesn't have to end there. As the scientists who put all this evidence together point out, understanding the problem is the first step toward fixing it. And they emphasize that even though the changes are huge, it is not too late for us to act and to avoid the worst-case scenarios.
And really, that's the question that's left, isn't it? The evidence is in, the planet's signals are coming through loud and clear, the investigation part is over. Now, it all comes down to how we respond.